Hi everyone. So now we are going to start with the particular topic heating effect of electric current. As we already know that when electricity passes through a current carrying wire or any other conductor, the conductor itself gets heated up. So to calculate this heat produced in the current carrying wire, we have a famous law called Joule's law, which tells us what are the factor on which this heating depends on or how much heat would be produced. So let's see what is the heating effect of electric current. So when we see, you can see that there are multiple appliances, there are multiple usage of heating effect of electricity. The bulb glows, it heats up and it glows due to the electricity. The water gets heated up in the electric kettle or in the electric water heater, or food get cooked in electric stove. So all this are the daily examples where we use the heating effect of electricity. Now the man behind to discover how much heat would be produced when current flows through the electricity was James Prescott Joule. Joule is a very famous and very known name, and we know that SI unit of heat itself is Joule. So let's know a little bit about this scientist. He was English physicist, also a mathematician, and he was also a brewer. He was born in 1818, 24 December, and he lived till 1889, 11th October. He was born in England and he was son of Benjamin Joule, who was a very healthy brewer, and his mother was Alice Prescott. So Joule was the person who found the nature of heat. Actually, he was working with heat and he found the nature of heat, and he discovered a quantity called mechanical equivalent of heat, which we know now as the quantity which tells us how much heat would produce when we do certain amount of work. Uh, the same person Joule was also the discover or was the founder of the law called Joule's law, which gives us the relation between different factors that gives the produced amount of produced heat when a current flows in a circuit. Now look at the Joule's first law, which is or you can tell that it's not Joule's first law, but Joule's law of mechanical equivalent of heat. So this particular law says that the heat would be transferred as work, or heat would be conserved as work, or work can be calculated as amount of heat energy. So his famous equation W equal to JH, where J is the amount of work done and H is amount of heat produced, which says that work is proportional to the heat and heat is proportional to the work. And here the proportionality constant J is what is called as mechanical equivalent of heat, and the value of J is 4.2 joule per calorie. This particular equation led the law of conservation of energy. Previously, when a certain amount of work was done, the energy was lost and there was no balance of energy. But using Joule's law, we found that if you do certain amount of work, there is a amount of energy which gets transferred as heat and it gets reduced by doing the work. So work is converted as heat, and that's how by this law we know that the conservation of energy has been verified. Also, this same law, or the same law which led to the law of conservation of energy, also gave us the way for the first law of thermodynamics. And that's how, from the physics point of view, at the early days of physics, this law is a very, very, very important law that we see in physics. Coming to the law that we are talking about, Joule's law of heat in current flow. In 1841, Joule found this law for heat, where he said that the heat produced in an electric circuit due to the current flow depends upon certain factor. And this law was called as Joule's first law. This whole process, where he told that the heat was produced by flow of the current, wherever, in whichever passage the current is flowing, be it a conductor, be it a conducting wire. So in whichever passage this current is flowing, that passage starts to radiate heat, and this is the reason why the channel itself gets heated up, and this process is known as Joule's heating or resistive heating or ohmic heating. Also, there is one another important aspect that tells us there is this current that will flow through the circuit. It will distribute itself, or it will divide itself in a various channel of a network in a way that the heat produced in the circuit would be least, which we know as the principle of least heat. So this is the very basic of Joule and Joule's law, which is very important for us to know. So let's learn Joule's law. But before that, if you like that video, then I have another video for you. If you want to know about Joule and his biography, then I have linked another video. I have made another video for which the link I would give you at the end of this video. I highly recommend you watch that video too.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.
So now let's learn how Joule's law and what are the Joule's law, how it is getting calculated. Now coming to Joule's law of heating. According to Joule, he said that if there is a electric circuit which has R amount of resistance and I amount of current is flowing, suppose for a time t, and because of this flow, because of this current flow through the circuit with the resistance R, there is a heat that is producing, which is H. Then according to Joule, he says that the amount of heat produced in the circuit will be proportional to the square of current flowing through the circuit. He also said that this heat would be proportional if with the resistance of the circuit and also the time for which the current is flowing. So finally, he told in his Joule's law of the circuit, which also called as the first law of Joule, heat produced in a circuit is equal to I square R T by J, where J is the proportionality constant and we also know J is the mechanical equivalent of heat. We know from Joule's law of heat that mechanical work done, the work done is converted into heat. With this particular equation given by Joule, work done is J into H, heat produced, and this J we have called it as mechanical equivalent of heat. So here also we know that this particular equation in terms of Joule. So Joule's equation of H equal to I square R T, it says that if I amount of current flows through a circuit for T time with a resistance R, then there will be a heat production. Amount is I square R T, that much joule. In the unit joule, I square R T amount of heat would be produced, or this can also be written as H or JH is I square RT, which is nothing but the work done. So the circuit would do the work as I square RT amount of joule, that much amount of work it will do. So this is Joule's law, which gives the how much amount of heat would be produced in the current circuit. If you want to convert it with in the calorie unit, we know that J is 4.2 joule per calorie. So when you substitute, your work done or heat produced will be I square RT divided by 4.2. This amount of work or this amount of heat will be in the calorie unit. So either the heat produced will be I square RT joule amount of it, or in the calorie you can calculate it as I square RT divided by 4.2 calorie of heat.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.